Hello, welcome back. In this video we will see some operators that can be used in Java programming. Really, operators are very vital for the any programming language or in developing any software or writing any code for the any application. So operators is basically very important for the any programmer or any language. So let's see the operators in Java. So some operators are very easy that you usually use in your real life, like arithmetic operator, and some are like a plus, minus, multiplication, division, percent, that is mod. So these are the arithmetic operators which can be used on binary, can be used as a binary operator. These are the binary operators. There are some more binary operators. Look, binary operators are those operators which takes the two arguments, two operands to operate its task. Like we cannot write plus 4, nothing, it's meaningless, but we write plus 4 plus 6, that means it's equal to 10. So it's plus is binary operator here because it takes two operand to work to perform its task. So these are the arithmetic operators which is very common or very easy to use. So next our operator is relational operator. So relational operator, what does it? Creates a relationship between two operands. So some of the relational operators are like equal to, double equal to, that compares the two variable, either it's equal or not equal. It can be used with the decision making statements, like if we will see this decision making in our next video. So equal operator, that is a comparison operator, or it's compare the two operands. So it's it's establishing a relationship between two operands. So that's why it's a relational operator. More relational operator is less than, greater than, less than, greater than, less equal to, greater equal to. Similarly, more is not equal to, that should be right like this exclamation mark and then equal to. It's means not equal to. So we can check any, like here we can check A is not equal to B, means either it may be true or false, and we can decide using decision making statements. Next statement operators is assignment operator. So assignment operator is something like this plus equal to. It means if you are writing, put a arrow mark here. Look, if you are writing a equal to, a plus equal to 10, it means you are writing a equal to a plus 10, means it will increment the value of a by 10, or it will add the 10 in the previous value of the. So it is the shorthand for the writing the operators. So more relational assignment operator is minus equal to, multiplication equal to, division equal to, percent, mod, that is mod equal to. These all are the assignment operator in Java. Our next operator is conditional operator, that we will see the conditional operator in at last. So let's, and our next operator is bitwise operator. So bitwise operator is better to see the program of bitwise operator. And next operator is logical operator. So we will see the program of the program that would be better to understand the conditional operator and bitwise operator and logical operator. So here we go. We will make a program to understand the conditional operator. So let's we have our main class and main method also. So let's take two integer variable. So I have taken two integer variable, int a and b, and let's take input in the integer variable. So we will have to make a scanner class object. here I have written scanner. Since scanner is in Java util package, so import java dot, it should be Java. Whenever you make any spelling mistake, the code hinting will not work in the Eclipse IDE. So here we go. Now we will take input. So let's write a message, system.out.println inside double quote, write enter value for A and B. So now we will compare these A and B using conditional operator, and we will find which has the max greater value, either A or B. So syntax for the conditional operator is, we write a condition, then we will put a question mark, then if this condition is true, then the task between this question mark and that is question mark and clone will be performed. If the condition will be false, that is the another part of the condition. So here the task between the clone and semicolon, that is a statement terminator, will be performed. So this condition must be binary condition, means it must return only two results, either true or false. This condition is true, then this part will be executed. If condition is false, then this part will be executed. So let's check using this conditional operator, we will find out the greater value among A and B. So here we will write a condition like A greater than B. Now think, if A is greater than B, then A is greater, so means condition is true, then the statement just after the question mark will be executed. So here we will write system.out.println A is greater, but it's better to store it in another variable. So we can write here, we will take another variable, like just take another variable m. So we can write here m equal to A, here semicolon, clone. Now if this condition is false, means A is not greater than B, then B is greater than A, B is obviously B is greater than A. If A and means A and B is not equal, that is the exception case here. Let's assume A and B has different value. So then if A is not greater than B, then B must be greater than A. So this condition is false now, then a statement after the clone will be executed. So here we will write m equal to B. So this way in the m we have the maximum value among A and B, but let's input first in dot next int B equal to in dot next int. Now it says multiple markers is here, we cannot take the it says syntax error token, it's a new kind of error. So let's remove this, and we can write like this, m equal to A here and B here. This is the correct way to write. If A is greater, then value of A will be assigned to M, and if B is greater, then this will be false and the value of B will be assigned to M. So sometimes experimenting the new thing is very exciting. So let's now print the value of m. So here we will write system dot out dot println since we have already assigned the maximum value in m, so we can print the value of m here. So let's run our program and enter. It says 123 is greater, or now enter the small value then greater value. It says, sorry, we have executed our program once again. So just press enter. It says greater value is this. So in this way conditional operator works. We write condition here, then statement for the trueness of the condition and statement for the falseness of the condition. So this is our conditional operator. Next we move to the our next type of operator, that is bitwise operator. Look, bitwise operator is very useful. Sometimes it's really make very use in the programs. So let's using bitwise operator, you must have some little knowledge about the binary form of the any integer value. Like if we create the 4 is the in decimal, we write this like this. In the subscript we like 10. So in decimal 4 is equal to 100 in binary. So this way we write here 10 and 2 is subscript. We can write here subscript or superscript. So in decimal 4 in decimal equal to 100 in binary. Similarly 9 in decimal is equal to 1001 in binary. So bitwise operator doesn't work on the integer value. It will convert the integer value into binary first, then it will operate on the operations, perform the operations on the binary form of the integer value. So let's see one by one. So for our convenience, let's assign a value in a and b. So here write here we need only two variables. So here let's assign a value a equal to, let's assign any integer variable that should be understood easily. So we assign here like 9 only, okay. And in b let's assign another variable like 12, okay. So here in comment side I write the binary equivalent of 9, that is 0 1 0 0 1, and binary equivalent of 12 also, that is 1 1 0 0. So this is the binary equivalent for the 9 and 12. So now let's perform some bitwise operator here. So our first bitwise operator is AND operator. So AND operator what does? So let's write sys system dot out dot println. Okay, here bitwise operator we write like this: a and b. Single and stand for the bitwise operator. So equal to, let's check the value of a and b, what happens. So put a plus sign to concate this, and inside the parentheses you can write for the convenient a and b. So here we are putting the and bitwise between a and b. So we if we check a, this will perform in convert the 9 in binary, that is 1001, and this will convert the 12 in binary, that is 1100. So 10 using AND operator, it should be in AND both the values should be 1, then only result will be 1. So here 1 0 1 and 0 will be 0, so here value will be value will be 0. First will be 0, then second will be also 0, and then third will be also 0, and last will be also will be 1, because 101 sorry 100 000 010 and 111. So here it will print obviously 8, because 1000 is the ASCII binary of 8. So here we can see it prints A and B equal to 8. Okay, similarly this way, similarly we can check for the OR operator. So here we will write OR is the single line, single pipeline. So A or B, so let's check the value for A and B. So here A is 9, so first 1 0 obviously will be 1, because in OR operator any signal will be true, the result will be true, means any of the two values will be 1, then result will be 1. Only if both result will be 0, then result will be 0, otherwise result will be 1. So in first bit their value is 10, so result will be 1, and in second bit this is 00, so result will be also 0. In third bit 01, so result will be 1, and in fourth bit 11, so result obviously will be 1. So if we run this, A or B will print the value as 13, because 1101 is the value binary, obviously binary of 13. So it's a 8 and A or B 13. Similarly our next bitwise operator is left shift operator. So here we go with left shift operator. Look, left shift operator and right shift operator works only on the one operator, so it's unary operator. So we can left shift only one value. So let's left shift A, and here we can write the number of bits. So let's shift the A with 2 bit. So here we will write, look, this is actual operator working, this is the message to print to make you understand what is going on in the line. It's clear? So there is this is the actual bit shifting with A. This is only message to print here in output. So what happened here? Let's value of A is 1001. Now if we shift these values 2 bit, so this 10 will become, right now the value of 9 is in 6 bit. Since we are shifting these values 2 bits left, this will be shifted to the next bit, so from the right side 2 bit will be empty, and it will be automatically filled by the 0. So this will become like this, 1001, and 2 bit it will shift towards the 2 bit. Like if we have this way, now this will shift 1 bit and 2 bit to the left. So here in right side 2 bit is become empty, and that will be filled with 20. Now I think this is the binary of, let's check the result, 36. So the value of A has become 36 in this line. Similarly we can perform right shift. So let's perform right shift. let's perform the right shift with b variable b. So here we will write, we will write b. We first we write operand, then we write operator, and let's shift the b with 2 bit. Okay, so what was the previous value of b? It was, or it's 100. Now it shifts towards right 2 bit. So here is the our current right bit. Now if we shift this 2 bit towards right, 1 bit, 2 bit, sorry, it's goes 3 bit. Here see the cursor here, it's current bit. Now 1 bit, 2 bit. What happens? These two zeros has shifted to the right side. Since our buffer memory or any memory will start writing towards right, so these two zero will be clipped or trimmed from the 1100. So the our final value to the b will become 11 only. That is the ASCII code of 3. So probably the value of b right shift b will be 3. So here we can see value for the b is 3. So this is the left shift and right shift for the a and b. Similarly we can perform one more operator, that is not operator, and one more operator is here bit right shift equal to, or left shift equal to, also by putting the equal to sign here, so we can put, it's obviously same because we are shifting 2 bits or equal to 2 bits. It doesn't give any difference, or it doesn't provide any much difference. So these are the some bitwise operators. Now let's move on to the our logical operator. So let's check the how logical operator works. Okay, one more operator is in bitwise is very important. Let's check a JOR operator, how JOR operator works. So here we will put the JOR operator with, since JOR is, so we will write like this, put a tilde sign before the a. Here we go. Now let's it says -10 for the value of 9. So let's check the value of -10 in binary will be, value of 10 is 1010, that is the value of 10, and for the minus it will put a so let's move to the so let's move to the logical operator. So delete this. Now we will need some, let's create a boolean variable. Boolean a comma b. Let's assign some value. A equal to, let's give it, true, and b equal to false. We have created two variables a and b as a boolean, and we have assigned them a true and false value. Now let's check we have three logical operators, and or and not. So let's write here a and single AND is bitwise operator. As you have already seen, we will put double AND. Double AND stand for logical AND operator. So in A and B, so and is and returns the value as true only if when both the signals or all the signals is true. So here A is true but B is false, so output will be false. So it says A and B is equal to false. Similarly, we can check for the not OR operator. So we will write here OR, that is two pipeline or two straight line here. So this will result true, because in OR operator any of the signal is true, then output will be true. So it's return true. Let's check NOT operator also. So NOT operator is works on the only one operator. So let's write a NOT sign before B. So it will convert the it will change the value of the any variable from true to false or false to false to true. So since right now value of B is false, so it will print true. So here we can see not B is equal to true. Similarly, value of not A will be false, because value of A is true. So here we will write A, it will print false because value of A is true. So it displays not A is equal to false. So these are the some operators which can be used in Java programming. So, yes.